Hello and welcome to AWS Purpose-Built Database Strategy, the right tool for the right job, as part of the AWS Innovate Online Conference. My name is Blair Layton and I'm the Business Development Manager for Database Services in Asia Pacific. I'll be taking you through how the database market is changing, why you should be considering using the right database for the right job, and providing an overview of some AWS database services. The database market is changing considerably. From the 1970s to the 2000s, relational databases reigned supreme. However, in the 2000s, as the internet grew, people started to hit problems with relational databases. This resulted in Amazon developing the Dynamo technology and an associated paper that was published in 2007 that led to the development of DynamoDB in 2012. We have seen a number of other new databases released around this time, such as MongoDB, React, Cassandra, and CouchDB. This means that there is far more choices in the database market today than there has ever been before. Now let's take a look at a traditional application and database architecture still in use today, especially in the enterprise market. You have a client tier accessing an application or web tier, then the access to the relational database. That database is used for all workloads and all types of data, whether it is simple key value access, complex queries, or even heavy query analytics that require full table spans. The one relational database is expected to perform all these tasks effectively. Over the years, as new types of workloads and data have evolved, the relational database has evolved with these demands to be the Swiss Army knife of database. But is it trying to do too much? When deploying applications in the cloud, we believe that you should choose the best database or data store for the workload, rather than try to expect one monolithic database to do it all. If you have a lot of read requests on a set of data, then it is more suited to be placed in a cache. Simple key-value data, like checking the status of a package delivery, can be pushed into a NoSQL database. Analytics can be moved to a dedicated data warehouse. Logging in the database is something that we see quite a lot of, but it can take up more space than the core application data over time, so it's best to move it out of the database. Searching of data should be allocated to a database that is specialized in this task, such as Elasticsearch. There is still a core responsibility for transactional systems for the relational database, especially when complex queries are needed with traditional relationships and joins. When building your applications, you should look at the characteristics of your application requirements to select the right database. If you need referential integrity with strong consistency for your transactions, then a relational database is still the best database for the job. If you just need simple key-value-based queries that operate very fast and have a very high throughput, then a NoSQL database like Amazon DynamoDB will be a good fit. Documents, such as those represented by JSON, are now a common storage requirement. And if you need to index and process these documents, then DynamoDB supports the document model too. In an interconnected world, you may find that relationships you try to model look more like a graph. For example, in a social media application, there's relationships between people. To help solve these problems, we have a new database in the preview called Amazon Neptune. For caching requirements, we support Redis and Memcache too. Finally, if you need a search capabilities, then Elasticsearch, as I mentioned before, is a great database for the job. At AWS, we have a large set of database services for the workloads that I just went over, but there are many other aspects of data management and processing that we can help you address too. If we start from the bottom on this slide, you can see that we have a number of services to help move data around, whether that is for relational databases with the database migration service, physical storage with Snowball, or streaming data through Kinesis. At the next level, customers are building data lakes on our object storage services, S3 and Glacier. Glue is a service from ATS that provides ETL capabilities and a data catalog to help you find and manage your data in your data lake. Moving up again, we have operational databases and analytics services to meet your different workload requirements. Finally, at the top, we have Amazon QuickSight for data visualization and machine learning capabilities with Amazon SageMaker. For the rest of this presentation, I'm going to concentrate on the operational databases highlighted here. I will also show a demonstration on how easy it is to use our managed database services. Why would you use a managed service instead of running your own database on premises or even on EC2? Well, have a think about how much time your DBAs and other IT staff spend on things like provisioning hardware and storage, installing, upgrading and patching software, managing documentation, licensing and training, doing backup, recovery, data load and unload, and security too. Then ask yourself, is that really adding value to the business? If you host your databases in EC2, then AWS can take care of the infrastructure components from the data center up to the operating system installation. But you will still have to perform the operating system patches, database installation, database patches, backups, manage high availability and scaling, and of course all the way up to application optimization. If you choose a managed database service, such as Amazon Relational Database Service, or otherwise known as RDS, then the only thing you need to worry about is your application optimization, with AWS taking care of everything else. This allows you to focus on what really matters for your business. RDS, given its name, is focused on relational databases. It offers a managed service for MySQL, Postgres, MariaDB, Microsoft SQL Server, and Oracle Database. Amazon Aurora is Amazon's own database platform and comes in two editions, one with MySQL compatibility and the other with Postgres compatibility. As a managed service, RDS is easier to administer with no need for infrastructure provisioning or installing and management of the database software. It is highly flexible, allowing you to scale your compute and storage with a few mouse clicks. It is highly available and durable with our multi-AZ capability that keeps a synchronized copy of a database in one data center and then another standby in another. Daily backups are sent to Amazon S3 with 11 nines of durability, and we also send the database logs to S3 every 5 minutes. RDS is fast, with the ability to use our largest instance, the X1E, with RDS Oracle to give you 128 vCPUs and 4 terabytes of RAM. You can choose between the high-performance SSD storage too. Now I'd like to talk about Amazon Aurora that is built upon the RDS platform. So what is Amazon Aurora? It's a MySQL-compatible and Postgres-compatible relational database platform with the performance availability of the commercial databases at 1/10 the cost, all delivered as a managed service. AWS announced the MySQL-compatible edition at reInvent in 2014 and the Postgres-compatible edition at reInvent in 2016. If you are going to build a new database for the cloud, then you don't want to use the same architecture that has been around since the 70s. AWS decided to build a new database platform using a service-oriented architecture. The storage layer has been broken out into a separate database-optimized storage service that receives database changes in the form of log entries, not file system blocks. This is a huge difference and the main benefit of the Aurora platform. The storage is located across 6 locations in 3 AZs and kept consistent by the storage service. There is a quorum of 4 needed for an acknowledged write and 3 for a read, providing a highly resilient storage tier. Backups are continuously taken from the storage service and integrated with Amazon S3 with 11 nines of durability. You can also create a manual snapshot and save that in S3 too. When Aurora is compared with MySQL on the same hardware, it provides up to 5 times the throughput. It should be noticed that this is not a single query running, but lots of connections running lots of queries. For Aurora Postgres, we can achieve up to 3 times more throughput on the same hardware. If you would like to know more, AWS has published the benchmark information and how to replicate the benchmarks on the AWS website. On Amazon Aurora, there is a primary instance and a read replica. There is no need for a standby instance that can't be accessed like an RDS MySQL. This is because the read replicas become failover targets in Aurora. With the read replicas operating on the same storage as the master instance, there is minimal lag, typically less than 20 milliseconds. This solves a big problem for MySQL users who often have read replicas that lag into minutes. Now I'm going to go and show you a demo of RDS. Welcome to the demo. What you're looking at here is the RDS console. This is the brand new console, and you can enable this when you go in to look at the RDS console on your own screens. So what you're seeing here is a description of all of the resources and things that are available. And as you can see, there's a number of different things, including the instance. So we're going to click on that, and you can see that I actually have one available instance for us to look at. But what I'm going to do is launch a new database. So you can see here we've got Amazon Aurora, which is our MySQL and Postgres compatible enterprise class database. Then we have MySQL, MariaDB, Postgres, Oracle, and Microsoft SQL Server. Now, what I'm going to do is select MySQL, and I'm going to create a dev test instance for this. So I click Next, and then that will take me to the next screen. So here you can see there's a few options. We do recommend that you use Amazon Aurora for production workloads, and then I'm going to create a dev test workload, so I'm just going to use plain old RDS MySQL. Then click on Next. Here are all the details about the RDS instance, and here is the version of MySQL that I'm going to choose. Now, because this is a dev test instance, I want to use the latest version available, so I'm going to change that to 5.7. And if we go further down, then we've got to look at, okay, what is the instance class? So this is what size is the instance that I want. Now, dev test instance, I think 2 vCPUs and 8 gigs of RAM for a T2 will be good enough. You can, if you want to, change it to multi-AZ, but I'm going to keep this on no because this is a dev test instance. On the storage, there are 2 types, general purpose and provision IOPS. I'm just going to leave that on general purpose, but I'm going to change this because I want a lot more space for my development, and I'm going to put that at 500 gigabytes. Now, what you can see down here is that we can see the price, and I'm thinking, whoops, maybe I don't quite need that much storage. I can change that and put that back to, say, 250 gigabytes. And you can see the price has now come down. So that's just an indication of how much it's going to cost per month. We get down here, we need to give it a name, so I'm just going to give it Innovate. And then we need to give it a username, so I'll use my name, Blair. And then we need to give a password, and you have to enter that twice to make sure it's absolutely confirmed. Once that's done, we click on Next. Now, we don't want to save the password, so I'm going to keep that. Now, I've got a default VPC, and I'm just going to leave that. This is from something else I did earlier. I could make this publicly accessible, but I definitely don't want that for a dev test instance. And then you can choose your availability zones. So I have a VPC with 2 subnets and different availability zones, but I don't really care for this dev test instance, so we'll just move on. Now, for the security groups, I actually just want to choose something I have before, so same from the DMS lab, add that. And now we're going to go down and look at a few other things. So we've got the database name, this is just a test, and then the database port, we'll leave that as the default. And then we've got some things we can use for parameter groups and option groups if you want to change some of the MySQL options. Coming down, then we can enable IAM authentication if we want, but we don't need that. And then we could enable encryption just by clicking on this and then using the default provided key, but we don't need that for a dev test instance. And then we're looking here at backup retention. So 7 days is the default, but I can actually increase that to 35 days, or I could turn it off completely if this was something just very quick that you wanted to play with. But for dev tests, 7 days is good, and I can actually select a window of when I want this to happen. But for this, I don't really care as long as the backup is done. Monitoring, we can enable enhanced monitoring, but I'm just going to leave that disabled. But there is one thing I want the slow query log available and make sure that's exported to CloudWatch. Now, going down further, maintenance is really important. So we want to have auto miner version upgrades to get the latest versions when they're available. And then for that to happen, another maintenance, I can choose the day. I want that to happen on Sunday. And you can fiddle with the settings here that are all in UTC and change those to the time that you want. And then we launch the database instance. So now the instance is being created, and then we can go back and look at what's happening with it. And as you can see, not much going on at the moment as it's just being created. So we can go back to the instances and see, yep, it's been created and there's an existing one there. Welcome to the second part of the demo. What we're going to do here is take this Oracle database and we're going to make some changes to it. So first of all, if we have a look at it, you can see at the top that it's got the version, it's got the instance that it's using, and then if we go further down, there's some metrics around CPU utilization, the number of connections, write activity, but as you can see, there's not a hell of a lot going on at the moment. We're just using this for test, and you can see nothing really happening. If we go down further, there are some details that talk about a number of different things, including you can even see the secondary availability zone because it's in multi-AZ, and then the primary is in Southeast 1B. So the secondary is actually in 1A. Then going further down, you can see that there's more information about alarms, the snapshots, and these are the backups that are occurring. And then at the bottom, there's some audit logs as well that you can look at. So what we're going to do is go back to the details section, and you'll see there's a modify button that we're going to click on. So we click on that, and then it will bring all of the options up that I can actually modify for this instance. Now, once that comes up, what we're going to do is to actually change the size of this particular instance. And what I want to do is make this twice the size of what we currently have. So here you can see, here's all of the different components that we can change, and here's that instance class. It's a M4X large, 4 vCPUs. I'm going to make that 8 vCPUs and 32 gigs of RAM. So once I click on that, then I can go down further, and you can see there's all the other options that we could have modified, but I just want to keep it like this. So I'm going to click continue and just modify that one thing. Now at the top, it's got a summary of what we're going to change, so just that one item, and then we can choose to apply immediately or keep this to the scheduled maintenance window. So I'm going to keep it to that maintenance window, and what's going to happen is when I apply this, it's going to be put into the queue, and it will actually change the database size when I click on the modify DB instance. So once that's done, what we've done is actually resized the database. It's still in its current size, but once we go into the maintenance window, then it will automatically happen. And that's a lot quicker and a lot easier than what you would be able to do on premises today. It's very difficult on-prem. Thanks for watching the demo. DynamoDB is a managed NoSQL database with low latency and highly durable storage. It's designed for Tier 1 applications. It offers massive and seamless scalability, with some customers writing in excess of 1 million writes per second to a single table. DynamoDB offers an amazing feature of providing consistent single-digit millisecond latency at any scale, even when scaling size or throughput requirements. The storage is located in 3 facilities in all regions, even those with 2 public AZs, to provide high availability and durability. It's easy to use with simple APIs to get and set information. It supports both key value and document models. And there are no table size or throughput limits. Some of the popular use cases for DynamoDB are ad tech, IoT, gaming, mobile web applications. A consistent use case across many different industries is user profile and login management. Often companies will hold a large promotion or event that requires many users to log in all at the same time. For example, a gaming company could send out a notification telling users to play the game now and receive a gem, or a telco could launch the latest iPhone at a specific time. Each of these situations will create a logon storm that relational databases would struggle to deal with. DynamoDB is able to scale up for the promotion and then back down again afterwards, so you only pay for the throughput that you need when you need it. The DynamoDB service has been around since 2012. So if you have looked at it a while ago, you might not be aware of some of the fantastic new features added over the last year or so. In February last year, we introduced the Time to Live, or Time to Live, or TTL feature. This allows you to tell DynamoDB to delete data after a specified period of time and makes it much easier to manage high throughput data that you only need for a short while. In April last year, we introduced VPC endpoints, removing the need for your DynamoDB calls to go out onto the public endpoint. Also in April, we introduced the DynamoDB Accelerator, or DAX, that allows you to put a write-through cache in front of DynamoDB, but keep using the same APIs that you use today. This can significantly speed up read operations and reduce costs on the throughput capacity that DynamoDB needs. A big feature in June last year was auto-scaling. Rather than having to manage the throughput requirements on each DynamoDB table, you can now specify some limits and let DynamoDB manage the rest. In November 2017, we announced global tables. This is an important feature as more customers deploy their applications across the globe and want to have a single source of key application data in one place. At the same time, we also introduced backup and restore. Even though DynamoDB stores its data in 3 facilities, some customers want a protection against user errors such as accidental deletes and removing a whole table, and this functionality meets that requirement. Last but definitely not least, we introduced encryption at rest in February this year. For enterprises and regulated industries such as financial services, this has been a big request. Amazon Neptune is a new, fully managed graph database from AWS. It's in preview at the moment, but should be generally available later this year. It's designed to be very fast, enabling you to query billions of relationships with millisecond latency. It also has the same level of durability as Amazon Aurora, with 6 copies of your data spread across 3 availability zones. It's easy to create graph queries with support for Gremlin and Sparkle, plus it supports Apache Tinkerpop and RDF graph models. While many customers use relational databases to solve graph-based problems today, there are increasing demands from different domains for more complex graph processing. As you can see on this slide, there are 3 different domains, one from a social news feed, another for restaurant recommendations, and the last one for fraud detection. We also see graph problems in more typical industries, such as route planning for traffic management and logistics, or network route problems too. The 2 caching solutions offered by the Elasticcache service are Memcache and Redis. So let's take a look at each engine. Memcache is an in-memory cache with a multi-threaded architecture that can consume multiple cores. It doesn't support any persistence model, so you have to design your application to deal with cache failures. Memcache only allows the storing of string values, so for some users this can be a deal breaker. It does scale well horizontally by adding new nodes and sharding the data across each node. Redis is a more advanced in-memory cache, but it is single-threaded. It supports read replicas, and in version 3, Redis added support for clustering to scale out. The persistence model allows you to take snapshots and create new instances or clusters from those snapshots. Or atomic operations allow you to use it for counters and other critical operations. There are also advanced data types such as ordered sets that are great for game leaderboards, top article lists, and so on. Some customers even use the pub/sub messaging features like a queue. And we do see most customers using Redis these days. Why is in-memory caching becoming more important today? Everything is becoming connected with the rise of IoT, from phones and tablets to cars, air conditioners, and even toasters. There's a demand from users for real-time performance with online games, ad tech, e-commerce, and especially social apps. For example, if your parents are on holiday in another part of the world and they upload some photos to Facebook, you expect them to be instantly available for you to view and load as quickly as possible. This is a difficult problem to solve. Load from these types of applications can be spiky. For example, a promotion for a game or an online sale at a web store will drive many people to an app or website. Or maybe it's just 6 p.m. on a rainy Friday night and everyone is trying to book a taxi at the same time. In many cases, the database becomes the bottleneck in overall application performance in these situations. To help alleviate reads from the database, the best thing to cache are small, frequently accessed items, such as products in a catalog, session information from a game, and top articles on a news site. This can greatly reduce the demand on the database and then increase the scale of the application without needing to increase the size of the database, lowering costs. That brings us to the end of this section and the overview on the operational database services from AWS. In summary, I discussed that the database market is changing with a plethora of new databases and data stores now available for you to build applications. Relational databases, while still being good for most use cases, are not the best solutions for all your workloads. You need to understand your application requirements and map those to the best database for the job. We then went through how AWS provides a comprehensive data management platform that includes managed database services for relational and non-relational workloads. Looking at the complete platform for database and analytics on AWS, you can see there is still a lot we didn't cover today. There will be other sessions during AWS Innovate that will include discussion on some of these services, so do look out for them. If you are interested in learning more about what I've discussed today, you have several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced courses. Additionally, you can attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. AWS also has a wide partner ecosystem to help you focus on your success and take full advantage of all the business benefits that AWS has to offer. To learn more about APM partners and find the right one that fits your needs, please visit the AWS APM booth at our showcase. And finally, remember to validate your technical expertise with AWS certification. That brings me to the end of my session. I hope you found it useful. Do remember to complete the survey by visiting the link on the screen today. With that, I would like to thank you for attending AWS Innovate.